Welcome to this presentation. So we're going to be talking about BeamStack. BeamStack is an open source framework for running machine learning pipelines with the Apache Beam. We're really excited to talk to you about it today. So a little about the presenters. My name is Matthew, and this is Fumi. We're both product managers at Maven Code. A little bit about Maven Code. We're based in Dallas, Texas. We deliver incredible AI solutions to companies. We provision scalable AI ops, ML, anything that has to do with machine learning and AI, we do it. All right, a little bit about the agenda and what we're going to be covering today. First, we're going to start with the overview, and then we're going to get into why, how to use it, and then we'll have a roadmap as well as a call for participation so developers can get involved with this, and then we'll have a Q&A section at the end.
Okay, so let's talk about what BeamStack is, essentially. So BeamStack is a framework that makes it easy to run infrastructure-agnostic low-code, GenAI, and ML workflows. So it makes it very easy. You don't have to do too much coding. You just very low code. And also, the way it does this is it comes with a robust CLI, command line interface, that basically abstracts most of the complex operations around the GenAI and ML workflows. So how does that work? This is a flow of how you would say, if you want to initialize your cluster with BeamStack, for instance, to install the necessary resources, the first thing you would do is, as a user, you would run the BeamStack init command. This assumes that you already have the BeamStack binary installed on your computer. So you will run the BeamStack init command with the appropriate flag. For instance, in this case, we say we run the BeamStack init -m. That -m flag stands for the monitoring. So it says that you're going to install the monitoring, which in this case is Grafana and Prometheus on your cluster. So what then happens is BeamStack pulls, the cluster components to be installed from the registry using Helm package manager and customize as well. And then it goes ahead and initializes the pipeline runners, which is Flink, Samza, or Spark, depending on your preference, and the monitoring stack that, it's going to be installed, which is Grafana and Prometheus as well. So BeamYAML makes this super easy. Essentially, this is like the big overview, the big picture of it, how exactly BeamStack looks like with the infrastructure agnostic layer and the whole diagram. So the beginning of the flow starts with a user submitting the BeamYAML file to BeamStack, right? And over there on the screen, it says, BeamStack deploy pipeline. You specify the file you want to deploy, and then BeamStack receives the BeamYAML. And what it does is it spins up pipeline runners, your API runners. If you specify Flink or Samza, it chooses that for you. And if you have any reference data in your pipeline, so say for instance you have a people.csv file that you're referencing in your YAML, it would copy that data and store it in the PVC for you, so it can then be accessed by the cluster whenever it requires it later on. The next step is that the worker pool of harnesses deploys and makes sure to deploy the pipeline to the right location, essentially, within your cluster. And then Grafana and Prometheus are configured to monitor the pipeline and, retrieve metrics and performance data and things like that. And finally, you can then open up your dashboard with Grafana or Prometheus. And also, you also have access to Runner UI, which you can also open as well to check your jobs and inspect logs, if you will.
Yeah, so let's get into why you would need it. So let's talk about the first one, right? Configurable deployment environment. You're able to deploy in any environments. With a simple command, users can specify environment-specific settings, which is a really, really awesome feature. The ease of deployment with Beam low-code YAML. So all you need is the Beam YAML. That's it. It's represented as opposed to a Python SDK. So it makes it super easy to get the pipeline that you want to deploy. All right, and then the composable reusable pipelines. So this is for the custom transforms, the GenAI features. And what makes this really unique and awesome is the fact that you don't have to rebuild them every single time. You can adopt them to any existing pipeline, which is just an incredible feature, as we all know. And then the collaborative setup and for development teams. So the architecture makes it really easy for teams to collaborate. So it's going to streamline the process and make it easier for all the technical teams within an organization to be on the same page. All right, so let's get into a use case of why you would use it. So this is an example of a text embedding. So it's going to be saved to a vector database in this pipeline. So what you would do is first you would specify the website within the Beam YAML, and then it'll scrape the contents of it. And of course, it breaks it down into chunks, and those chunks get embedded, and then the embeddings get sent all to the vector store. The vector store gets pushed to the Elasticsearch, And then the user is going to be able to question a query into it using the OpenAI and LLM.
So how do we use BeamStack? The first thing is, well, you have to install the binary from GitHub. So if you go to the GitHub repository, select the version that's compatible with your computer, you just download it and install it. The second step is to configure the target environment, basically just initializing it with the resources as will be displayed shortly. Then you select the YAML package that you want to deploy. So, as ML engineers, you might have multiple pipelines that you're working with. So you just specify with the name tag, and then it deploys it. And then the final step is to actually monitor your jobs with Grafana or the Runner API. So this is the first step, right? So this is how we're initializing it. So here, BeamStack has been initialized with monitoring, which is -n flags. So it deploys your CRDs, creates the deployments, and installs the Flink operator. This is the Flink operator. We're using this as a Runner API. And now you can set your Grafana password and username so you can open up the dashboard later. It installs the monitoring stack, and then you're good to go. So once it's complete, you're fully initialized, and then you can begin to deploy, your pipelines to the resource, to the cluster. So again, this is how to deploy a pipeline. So you see deploy pipeline, the test.yaml file is the file that you're actually deploying. And then the Flink flag, basically, so when you create a Flink cluster, you have to specify the name. In this case, it's Beam Summit. So in order to verify that the Flink cluster is actually created, we can use Kubernetes to actually get that. And we can see that the status is container creating. However, you should wait for the status to change to running before you actually, check your Runner UI, which is the next step. So here we're just going to open up the Flink Runner API UI so we can actually check our job and see if it's running, what the status is, and if it's failed. So we do that by using the BeamStack command. It forwards it to the port 80 by default. You can specify the port, if you want to change it, or if you have something else running on that port. So right now there isn't any job, probably because the container is running. So if the job has been created and it's running, and in a matter of moments, the job will be completed, and you can actually inspect the logs, check out your custom transforms and other configuration management tools, if you will. That's how it's done. So now we're going to talk about roadmap.
Yeah, let's get into the BeamStack roadmap for you. All right, so as we discussed earlier, the CLI tool is what we have, and that, of course, is going to initialize and deploy the YAML pipeline to the Kubernetes cluster. And then we have the BeamStack transforms here. Now, for the transforms, we have a really good number, but we are going to be adding more. So that feature is going to be obviously very pertinent. It equips users' ability to perform custom data manipulation transformation, which we all know. And next on the line is to be able to support multiple Beam runners. So right now we only have Flink, and then we're going to be adding more as we go along. We're adding Spark, Sansa, the whole nine. API documentations, that's going to be next. Of course, we're going to provide thorough documentation, all of our features, all of our usage. It's going to contain all of our versioning, and every single technical information is going to be comprised within it. And then we have the SDK, which is going to be on the very last, and that's something that we are super excited about. We can't wait to package that, and of course, we're going to be needing help with that. It's going to be able to provide super fast, going to be customized. It's just the customization aspect of it is what people are going to really draw them towards this. All right. So this is a task breakdown. So we already have the architecture, and of course, it's ongoing. We have the BeamStack website, which we will provide for you at the very end of these slides. These are some of the basic CL commands, and we do have additional ones, but these are the ones that we listed. We can initialize the Kubernetes cluster, create the Flink cluster, create resource information, open Grafana, as Fumbi just displayed for you, open the Runner UI, and get help from any command. So ongoing is the custom transforms. Like I said, we are going to be adding more, so you can be able to customize your pipeline to fit your specific needs. API documentation, as I just discussed. The integration with data stores, obviously Elasticsearch is what we have. That's what most developers use, but we will be adding more vector stores to see fit. Because the whole purpose of this is for you developers, right? So any feature that you need or anything, you want to be able to do that because you guys are going to be ultimately utilizing this tool. So pending is the multiple runner function that I just discussed, and the modeler monitoring and observability. So that's going to be able to customize the monitoring dashboard for you. And then the BeamStack kit that I just discussed. So this is how we're tracking our features, just typical GitHub app for you. So I have all the features listed on there for you. So you'll be able to go through and see which ones that you could help if you be so kind to do so.
So we want, people to be able to participate in the projects, students, professionals. We have our website that contains pretty much a lot of information that you would need, documentation that contains the architecture explanation, the overview, the diagrams and use cases, and the technical concepts as well. Pretty much has all the information that you require. There's also links to the Discord channel there. There's also a tutorial section on the website that you can navigate to watch videos on. If you want to follow, how to deploy the pipeline to create multiple clusters and basically do whatever you want to do on the website. So how I see it is we have two main, shall I say, swim lanes for contributors. There's the code contributors and there's like the, shall I say, product adopters. So with code contributors, you can come in, you can, help us with the features we're building, build out a roadmap, implement more features. And with product adopters, if you're a tech professional or you're a company, it would be really nice to have you, present us with use cases so we can actually expand the amount of use cases that BeamStack currently covers. And it would be also lovely for you to join our community. We primarily use Discord right now. So again, the link to the Discord will be shown right after the slide. Just come, contribute, request to be a contributor, and it will be really, really lovely to have you on board. Thank you. There's the QR code to the Discord if you want to join, and all the links to the website and get it as well.